Thank you for watching Knowledge Academy. All right, so let's talk about what is a dot product. Probably you learned about this thing before, but what is a dot product? Dot product means, you know, I want I want to find similarities and differences, right? Similarity and differences means I have two ways I can do vector. I can look into the vector. Number one is I have vector number one. I have vector number two. I can call them vector A, vector B. Are vector B and A are in the same direction? Yes or no? Vector B and A are in the same direction?
Yes.
Perfect. So if I want to asking you how these two vectors work together, they want to work together as a productive, right? They work as a productive. So one word is productive, but another word is that I have one vector here and one vector here. They're gonna work together as a destructive, right? Destructive means they're gonna destroy each other, okay? And productive means they're gonna support each other. They're gonna produce something as a mutually together, okay? Now, this is the outcomes of a this is the outcome of a two vectors operation, right? Now, if I want to turn something, this is a word when I want to push or pull something. If I want to push or pull something, I use this. If I want to turn something, right? If I want to turn something, so let me ask you one thing. This is a vector A and this is a vector B. Do you think vector A and vector B have a capabilities to turn to each other? Do they have a capability to turn each other? No, they could not. So if vector A is here, vector B is here, right? They have a capability, they can turn each other like this way. They can rotate each other pretty much. When I'm talking about the rotate, I use a thing called cross product. And when I want to push something or pull something, I use the word dot product. Okay, that's one thing. Anyway, so what I'm going to do, I'm going to be talking about dot product for now, and maybe some other day I will talk about cross product. We have a topic in the cross product as well. So I'm going to eliminate this cross product. And let's talk about dot product a little bit more. Dot product capture or calculate how much two vectors are parallel, right? It means if I have a vector, okay, if I have a vector A, vector B, if I'm asking you what's their product, you're going to multiply vector A and B, and you're going to multiply, let's suppose vector A is 5, vector B is 6, you multiply them and you get the answer is 5 times 6 is 30. Okay. So we're going to learn about how the dot product working, so it's going to be 30. But let me do one more example and talk about that. Now, I change vector A this way, vector B this way, right? Vector B this way. So can you guys look at the last thing I just draw? Vector A, vector B. Do you think vector A and vector B are parallel to each other? Vector A and vector B are parallel to each other.
No.
No, they are not. But They are not absolutely opposite to each other. So what I'm going to do, I'm going to take this vector A, split this vector, and I'm going to take this guy and I'm going to drop it here. So this is my vector A, this is my vector A part. So these two parts, the one, the white color one I just draw it, is called AX, this is called A. So really, if I'm asking you, can you calculate the dot product of A, X, B? So let's suppose this A is 4. This is again vector 5, vector A is 5. This vector AY is maybe, right? AY is 3, AX is 4, A is 5, B is 6. Can you tell me what is the answer for AX times B? AX times B. What is an answer? 24, right? You multiply this 24 to 6 and answer is 20. So you notice one thing. It was used to be 30, now it dropped to 24, right? And that's exactly what this dot product it means we are calculating. That's like a summary of the dot product. Let's jumping into that and do more work with dot product and go from there. Okay, so let's continue. Let's say dot product. Dot product to vector is a scalar quantity. Number one, of dot product of two vectors is a scalar quantity. Okay. Dot product of vector scalar quantity means when I ask you dot product, you only give me the answer. Means no direction. No direction. You don't need to give me the direction. Only magnitude. Only magnitude. No direction, only magnitude. This is the two things you have to learn very hardly, that we're not going to produce a direction. Scalar product, dot product also called scalar product because they are scalar. A dot B, and the formula is A magnitude, then B magnitude, then cos theta. And what is the cos theta? Let me go back here. Cos theta is the angle between B and this little portion of this A. So basically this angle is this. Or if I want to draw here, I'm going to draw like this. I'm going to say it's vector A here, vector B here. This angle is, and really when you drop this projection of A is going to be look like this, is called AX. So this is angle. So I'm going to say that theta is the between A and okay. Number 3, it obeys cumulative law. It obeys cumulative law. It's a commutative. Commutative is a little bit different across product. Commutative law. And what is the commutative law is, I can say A times B must be equals to B times A. Just like 4 times 5 must be equal to 5 times. That's the law. So I'm going to write like this. A dot B. You see I'm just using here as a dot. That's why it's called dot product. That's why you must be writing this dot. You cannot say that A cross something else. not say that. Somebody asking you dot product, you have to write like this, A dot. Okay. And I'm going to say A dot B equals to B. Okay. So let me ask you one question before I write in point number 5 or 4. um, if two vectors are perpendicular to each other, if two vectors are perpendicular to each other, if A and B are perpendicular to each other, do they try to support each other when you want to multiply them? They want to actually support each other, or basically they consider destructive each other, or they do anything to each other. There is anything common between the two. Simple as that. If two vectors are perpendicular to each other, do you think there is anything common between the two in terms of direction?
No.
If two vectors are perpendicular to each other, do you think there is any common thing between the two, interaction wise?
No.
Not really. Remember, I'm measuring right now how perpendicular two vectors are. That's basically telling me they are not parallel to each other, right? They are not parallel to each other. So if one vector is this, another vector is this, their dot product, by looking, their dot product is 0. Let's prove it. If I'm going to substitute in the formula, right? If I'm going to substitute in the formula, I'm going to say that A dot B, A, B, and then I'm going to put the cos 90. When I put the cos 90, because this angle is 90 degree, what is the cos 90 value? Cos 90 equals
Mm.
to 0. So when cos 90 is 0, so the whole thing becomes 0. So by definition is 0, by mathematical is 0. So you know this. Number 5, I'm going to write one more time, same thing. Dot product measure how much two vectors are in the same direction. How much two vectors are in the same direction. Annoying, but so what are you going to do? We're going to be writing the vectors in terms of mode number. The dot product of vector u and v, I'm going to give you the vector in a specific form. U vector is ux, uy. V vector is vx. If I want to do the dot product, u dot v is equal to, what exactly you have to do? You have to multiply like this, ux comma uy dot vx. Multiply this to that, and multiply this to this. And so it's going to be look like this. Ux dot vx, uy dot v. Yeah, that's pretty much what we got. So you want to multiply. Let's take a look at another example. Okay, I'm going to do the example here. So given vector v, Vector v, I'm going to give some values, 7 and 2. And the vector u is 3 comma 6. Find v dot. Okay. So v dot u, I'm going to say is v dot u, or v dot u, I can say is v dot u, or I can say is u dot. Like, that's what we learn in commutative law. I can write like this, but either way, I'm going to multiply the two, so you can multiply them. So let's do one way or the other. So I'm going to be writing v dot u or u dot v. So solving into one way or the other is not going to make a difference. So I'm going to say is u dot v maybe equal to 7 dot comma 2 dot 3 comma 6. I'm going to multiply them. It's going to be 7.3 plus, it's not 7.3. I just use the dot for purpose. And 3.3 comma 6, sorry, 2 comma 6. 2 comma 6. So I'm going to multiply that and then multiply that. This is not 2.6. I use the dot for reason. So every time you write in dot product, guys, you do not write like A cross B. You cannot. You have to use the dot. Okay. And there is a reason behind it. 21 plus 12, and the answer is 33. Okay. So u dot v equals to 33. My question to all of you, does my answer is complete, or do you need the direction of these 33? Do you need the direction of these 33? Product. We talk about that? No, we do not. Okay. Let me go to next slide. Do some more problems. But before we do some more problems, we're going to be talking about u dot v equals to u1 v1 plus u2 v2, and these are the component of u. But if you have a 3D, this is a 2D. If you have a 3D, you're going to be writing u dot v is equals to, I'm going to write here u equals to u1, u2, u3, v equals to v1. These are the three-dimensional. So it's going to be u1, v1 plus u2, v2 plus u3. Yeah, that is three-dimensional dot product. And let's do yeah. This is how you're writing when angle is not given. Okay, so let me just write here. When angle is not given. When angle is given, you're going to be using this. U dot V equal to U magnitude V and then cosine theta. We're going to be using these two formulas when angle is given and when angle is not given. Make sure when angle is given, when angle is not given. Let's take a look at another problem. For u equal to, there's a vector given. I'm going to use these parentheses mean vectors. So 3 comma minus 1 comma 2, v equals to this minus 4 0 2, and w equals to, I have a three vectors given, 1 minus 1, and z 2. So we have four vectors, and all the four vectors are in three-dimensional format. We need to find the angle between each pair of vectors. Find the angle between each pair of vectors. Okay. So if you're talking about angle, which formula should I use? The top one or the bottom one? They're asking me the angle in this problem. Like this problem, they're asking me the angle. Which formula should I use? The bottom one or the top one? Bottom one, because top one I actually skipped the cos theta, so I couldn't find the cos theta. Okay. What I'm going to do, I'm going to use that bottom one. And the reason I just back and forth spending some time, so you guys distinguish the two. They are not same. You have to make a distinguish between the two. So I'm going to write that. The first one is A, angle between U and V. The B is angle between U and W. And C is the angle between V and C. So I'm going to do A and B and C, you guys be doing it. Okay, let's do A. So I'm going to say U dot V equals to U magnitude, and then V cosine, then cosine theta equals to U dot V, and then U magnitude, and then V magnitude. Okay. Now, let's go back to the topic again. These two vectors are given in a vector form, right, or component form. So in order to multiply the U dot V, which formula should I use? In order to find U dot V, which formula should I use? Here, this one. Yes or no? No, sorry, this one, sorry, bottom one, right? I'm going to using the bottom one to find in the theta, and I need to find out the top one to find the U dot V, because I in order to find this formula, I need to know this cos theta. But in order to find the cos theta, everything should be known. I know I can figure it out this, I can figure it out this. What I'm going to do with that, I'm going to use this formula to figure it out, U dot V. Okay, let's go back to the next one. And what I'm going to do, I'm going to do a little bit direct math here. So multiply, really I'm going to do multiplication of U dot V. So I'm going to multiply this to this, then this to this, then that to this number. Okay, let's do it here. It's going to be minus 12 plus 0 plus 4. Okay. The magnitude of u, the magnitude of u is, you already know, the magnitude of u is equals to x squared plus y squared c squared. These are the three components. So what are you going to do? We're going to do the same thing here, a little bit correct. So I'm going to say is u squared is 9 plus 1 plus 4, right? 9 plus 1 plus 4, and the v is 16 plus 0 plus 4. Let me just rephrase again what we got. We got if you add them together, it's going to be minus 8 divided by square root of 14 square root of 20. You can also write this thing is minus 8 or 2, 14, 5, right? 5 times 5 is 25. And then we took the 2 out. So it's going to be 20. If you multiply them, so 2 is going to say 2 times 2, 4, 4 times 5 is 20. So you this thing 20 you can write like 2 times 2 times 5, right? So 2 comes out. That's how it comes out. So don't be scared for this. This 8 and this 4 going to be canceling out a little bit. So it's going to be 4 for this. And I'm going to write is going to be equal to like that, right? Minus 4 for 14. If you multiply that 2, the answer would be 70, right? 14 times 5 is 70. Yeah. So what you're going to do, we're going to say is here cos theta equals to minus 4 70. So I'm going to leave, I want the theta here. I'm going to leave theta here. Let's say cos inverse 4, 70. Can you guys calculate first? You calculate and give me the answer. Oh, here's a minus. Okay. Remember, you should give me the answer what your answer gave the calculator, and calculator gave you the answer in radians. Use your calculator, everybody, put your answer in the chat. So basically what you have to do, if you are not remember how to calculate them, take minus 4 divided by square root of 70. Let's suppose whatever you get the answer, 0.3 or 0.4, whatever answer. Then go into your calculator. There's two kind of calculator. The first calculator you can hit shift button. There's a shift button and then hit cosine and then enter the value. The other calculator, you type the answer first and then go to hit shift or second. Some calculator says shift button, some calculator says second button. They call second. Start with 2 and then hit that one and then hit cosine key. You will get the answer. I hope everybody took those classes before, so you've used those options. And I get the answer is 0. Sorry, answer is 2.069 radians. Can you calculate? Can you convert this radian into degrees? Theta equals to 2.069 radians. Or can you calculate into degrees? 118, 118.56, 118.56 degrees. Let me just try to draw these two vectors. So look like vector u and v. So u is here and v probably right. Okay. Now, can you guys calculate this part and give me the answer? The part B, I'm doing it. Guys, just bear with me. So I'm gonna say is direct cos theta equals to u dot w and then u dot. So this one is 3 plus 1, 3 plus 1 and plus 4. Okay. And then it's gonna be u is gonna be 14, right? That's what we calculate earlier. Is going to be 14, right? And this one is going to be 6. Okay, so this is going to get the answer. 0 is going to be 8 and 84, right? If you divide them, what's an answer you got for cosine theta? If you divide them, what is an answer you got? 8 divided by square root of 84. 0.873, 0.83, and then I'm going to do theta equals to cos inverse 0.85. So when you do this one, what's an angle you got in radians? I got two answers, 0.510, and in degrees, this is radians, and in degrees, I'm going to say is it's supposed to be half, so 2 pi 180, so it's going to be somewhere, you know, let's say radians, just multiply this. In degrees, how much you got? Around 29.23, right? 29. Yeah. Okay, I'm going to start a real quick, a small topic. So let me start a new topic. It's a small topic, and maybe stay here to get the introduction a little bit. And it's kind of called direction cosine. Direction cosine means if I have a vector like this, right? I'm going to take the vector, okay, and this vector have pretty much like a 3D vector. So this vector would go this. This is a component, and the component of the vector of this component. Another component of the vector is this. So this is a vector v is called vx. This is a vy. This is a vz. All direction cosine means I need the angles, vector angles. Which angles? I want from x-axis, from y-axis, from z-axis. So this angle is from here to there. See what I'm doing? Starting from x-axis, go here. Starting from y, go here. Starting from z. I call this alpha. I call this beta. I call this gamma. So I need to find out direction cosine means I need to find out three angles, alpha, beta, gamma. That is called direction cosine. Direction cosine is also really a dot product, right? A dot product. So what you can do, you just take this vector and then this vector and taking a dot product. So let's suppose I'm going to be doing the dot product of alpha. So I'm going to say v dot vx equals to v, then vx, then cosine alpha. Well, not cosine theta, because here is the alpha, so I can just replace this theta to alpha. Now this Vx and Vx is basically, this is a unit vector, so I can call it basically the I vector. So I can rid of this U with I. It's a unit vector, so I'm going to call it U dot I. Okay. So here, cosine alpha equals to vi, right? Vi, or I can say vi, and then v full vector, complete vector. This because this one is going to be converted into one, so this is gone one. So I'm going to say this. There will be a one here, like coming from here. We don't write the one, so this is the direction. The second one is going to cosine back up. I can write simply here vj over v cosine gamma equals to vc over v. All right, let's do a real quick example. But before we do the example, the beauty of these direction cosine, in order to check your answer, right? There is a rule apply, and then you have to make sure, the rule is that cosine square alpha plus cosine square beta plus cosine square gamma should be all equals to. So if you find those angles, you can check if your angles are good or bad, or you have some mistake, you have to be redefine them. Okay. So let me do one problem. Problem here. Find the direction cosine and angles of the for the vectors v 2i plus 3j plus 4k, and show that right? Solution. In order to find v, I have to just do it one time calculation. So v equals to 2 squared plus 3 squared plus 4 squared, and it's going to be square root of 29. Use a formula equals to Vx or Vi over V. Here Vi is 2 over 29 square root. So I'm going to say is this one alpha equals 2. Cosine inverse of this is going to be, you're going to get in radians. You can convert it to degrees because I want to get in degrees. That's what we got. Make sure you guys checking those answers. And it's going to be Vj or V equal to 3 or 29. If you solve beta from here, beta is 56. Cosine gamma, we're running pretty much a little bit out of time. So VK, and it's going to be V 4 over square root of 1. And if you calculate gamma, equals to 42. Okay, so we got this answer. Okay, now I'm going to be taking the square root of those. So multiply them. So I'm going to prove it here, guys, real quick. Cos square alpha plus cos square beta plus cos gamma equals to 1. And here I'm going to be taking the square root of this term, like this term. So it's going to be 4 over 29. The square root of this 29 will be canceling, plus 9 over 29 plus 4 over, sorry, 16 over. If you add them all together, it's going to be 29 over 29 equals to 1. And it proves, right? Just prove that is the answer. Okay. Let's take a look at another problem. Okay, in the continuation of fraction cosine, here we need to find the angle theta between vector and in ABC. So find the fraction cosine. Okay, so here the vector is given like this u and 7i plus j minus k. Okay. Now in this vector we can write like this, or we can write in a different form. We can eliminate those parentheses. We can write like this. And if I'm writing inside the parentheses, I should keep in mind that I have to write inside the parentheses. I should not be using sign. So 7i j minus k. A little recap. We just put the arrows, commas, so we can separate those entities. Now, we know the direction cosine, cos alpha, cos beta, cos gamma. And they equal to uj, ui, uk divided by u magnitude, divided by u magnitude, divided by u magnitude. Okay. So first thing first, we need to find out the u magnitude. And the u magnitude would be like this: 49, 7 squared 49, plus 1 plus 1. And if I solve, it's going to be 50. So I'm going to substitute the value cos alpha equals to 7, which is my this component, and over 59, 51. And if I solve from here, the alpha comes out to be 1, 1. Make sure when you solve this thing, and take that cosine on the other side and take the inverse. So you can find alpha, then cosine beta equals to 1 over 51. And if I solve this thing, it's going to be beta equals to 82.0 degrees. Same thing, cosine gamma equals to 1 over 51, but there is a minus sign. Make sure I put this sign separate so you do not forget. We are not taking the magnitude of the numerator. Numerator is not a magnitude, it's a component. It's very important you do not ignore this minus sign. If you ignore this minus sign, your angle will be look like a little bit different than what it should be. Then you have to do another operation. You have to minus this angle with 180 degrees. So rather than we involve into those, we just want to make sure we keep the sign as is the way it comes in the question. Okay. Now we're going to take another question. It's pretty much same problems and same type of problem. And the u is given here. Minus 4i plus 3j plus 5k. And if I want to take the magnitude graphically, it's gonna be 16 plus 9 plus 5. So it's gonna be 36 plus 16. You can also write like this. And if I solve this, it's gonna be 5 squared. That's like u magnitude, or the length of the magnitude of a vector u. Okay, now here I'm going to say is cos alpha equals to 7, sorry, minus 4. minus 4 divided by 5 square root of 2. And if I solve here, alpha will be uh, 2.1721 is going to be same thing in previous one. I just write in radians, and you can convert this alpha into degrees by multiplying 180 divided by pi. Okay, so angle should be given in degrees. Cosine beta equals to 3, 4, 5. And if I found the alpha, sorry, the beta here is going to be plus, and if I found the beta here is going to be 1.1326 radians. And if I convert this beta into degrees, it's going to be 64.9 degrees. Okay, cosine gamma equals to 5, 4, 5, 2 is going to be canceling out. So it's going to be left over 1 over half, 1 over square root of 2. So gamma equals to pi by 4 radians. And if you multiply by 180 divided by pi, the answer will be 45 degrees. Okay, here I'm going to be doing one extra step. I'm going to confirm and verify my answer. And I'm going to apply this formula plus square gamma should be equals to 1. So if I substitute the value from the, from these values, like this value, and this value, so it's going to be look like this. Gamma equals to, it's going to be 16 over 50. So this is square 4 root and divided by 50 plus 9 over 50 plus 25. Add them together, the answer would be 50 over 50. And if you canceling out, it equals to 1. And we prove that this expression verify and validated. It means all my 3 angles are correct. If my angles, if this answer not coming out equals to 1, it means something wrong with my angles. I have to go and look into that. Okay. Now, let me just a little bit step back and talking about dot product, because this is fraction cosine is a extension of dot product. It's not a new topic. Okay. So what I'm going to do, I'm going to be just talking about dot product and their application. So let's take a look at the dot product. Let's take a look at another problem. And the new thing we're going to talk about, the first one is projection. Projection of a vector into in another vector. For example, I have a vector. Let's suppose if I have a vector u and I have a vector v. Okay, vector. Vector v is a little bit longer vector. So what I'm going to do, I'm going to move this vector here And really what's a projection means is, if I have a, if I, let's suppose if I have a light here, a light bulb, and I turn on the light bulb, what's going to happen? This light bulb is going to fall onto this vector and they make a shadow here. This is a shadow. The shadow you can call shadow, you can call projection. Projection of, so basically this projection of U on V. It's very important from what to what, U on V. Okay, so I'm going to do one example and then wrap up this one. This is quick topic, it's nothing new. It's just an application of dot product. I'm going to be talking about another application afterward this one. So I have a vector, for example, U vector is given in this problem 3i minus 5j plus 2k. And I have a vector V given 7i plus j minus 2k. A projection of U on V, solution, the projection of U on V. So you're going to be writing this new vector, the one I'm saying, this white color vector, which is basically nothing but just a shadow of projection. I should have a new name of this vector. I cannot say U, I cannot say V. Maybe you can call UV, right? Projection of U on V, you can call this, or you can call W, right? You can call W. So maybe I can call this vector AW, just for simplicity. You can name it anything. So I'm going to be writing, what is this W equals? The formula is projection of V on U, right? I'm going to write projection V on U equals to, this is just a formula. Now the solution you're going to be solving is going to be look like this. Which vector you want to make uh, the vector which is being projected is going to come only once. So you're going to come only once, dot divided by V square V. So you can see here, if I, the way you're going to writing vector U projection of V. So you can see here, U is coming here, dot V. Then the main vector is going to come with the magnitude square, and again they're gonna come here. So bottom line is that you can see V come here how many times? 1, 2, 3, and U only come here 1. So you have to remember the way it's written. It's very critical. If you flip the U into V, right? Let's suppose you flip, you forgot you say projection of V to U, you just say U into V. And in that case, you just solve everything and you think you are solving the correct projection of U on V, but they are not. But they are not. So what I'm going to do, I'm going to be writing vector V as is, and then V square. So vector V magnitude. So what I'm going to do, I'm going to say is multiply 3 to 7, 21, 3 to 7. I'm going to multiply this to this, and plus, and minus 5 to minus 5 to 1, plus 2 to minus 2, divided by V squared. So I'm going to take the V and then square root of their magnitude. So the square root of magnitude is 7 squared plus 1 plus minus 2, and then whole thing will be square. Make sure you take the square root before you cannot canceling out. You cannot canceling out because there is a magnitude here. You have to take the magnitude and then take the square root. So you cannot cancel this square with this, okay? And here I'm going to be writing vector V, which is 7i plus j minus 2k. And if I solve this guy, is going to be 21 plus 5 minus 21, going to be 4, and this one should be minus. So 21 minus 5 will be 16. 16 minus 4 will be 12. And this one you solve it, it's going to be 249, 50, 49, 50, 54. Okay, 54 with the square root, and then there's a square, so you're going to canceling out this one, and then the vector 7i plus j minus 2a. And there's not much we can do, so we can simplify it a little bit and then write like this, and that's our vector. Remember, this u vector is also a vector. I'm going to write in w equals to this vector, 14 over 9i plus 2 over 9j minus 4 over I. And that is our answer. Yes. Let's take a look at another problem, another example of or application of dot product. And the other application of the dot product is work. What is work? Work means you want to move an object from one location to another, and this object is basically whatever. So what you do when you try to push this object from here, you're going to apply force, and it's going to be from here to there. Right? So this is A position. You move this block or box to B position, and this distance is here. So what exactly the dot product of work done? So work equals to magnitude of force times distance. That's a formula for work done. Work done equals to magnitude of force and the distance. So maybe I can call this distance d. You can call d, or maybe you can call point p and q. So maybe you can say p. Yeah. And that's one case. But if the thing is, let's suppose you don't have a force in your same direction, you have the force in like an angle. You don't apply this force, you apply the force which is an angle. So what you're gonna do, you're gonna take the component of this force of this direction. So the bottom line is that if you have a force not in the direction of distance, you can only take the component of force which is along the distance. Only take the component of force which is along the distance. So what I'm drawing right now is red color. Maybe I can draw here. If the force you're applying here is this, and the block is moving in this direction, so this is angle is theta. So what you're gonna do, you're really gonna take this component, and we learned before rectangular component. So this component may be equal fx. So really the work done formula in this case, the new case I'm drawing right now, work done should be equal to fx magnitude times p. Let's suppose this is p again, and you move it to a new location form. So this is a new formula. So how can I write this formula? If I have a force is not along the distance, I'm going to be write like this. F cosine theta, right? And p. Okay. Now let's take a look a problem for this. And the problem is a car is towing using a force of 1600 Newton. The chain used to pull the car is making 25 degrees angle with the horizontal. Find the work done in towing the car 2 kilometers. Okay. Now in this problem, really what's going on? We have a car is being towed away, and the force applying 1600 Newton, and basically maybe the force is going this way, right? And we have a second condition is given. The chain using to pull the car is making a 25-degree angle with the horizontal. What does that mean? It means really I cannot draw this way, right? I have to yeah, it's making 25-degree angle. All right, so what you're going to do, we just want to be make sure we draw the correct diagram. So first of all, before we draw the diagram, we're going to be making this car. This chain is making a pulling here with 1600, right? And this is making a 25-degree with the horizontal. And how much you pull over here? You pull the car to 2 kilometers. 2 kilometers. We need to convert this 2 kilometers into meters, and that should be equals to 2000. Okay, that's first thing. So let's apply the formula. Work done equals to force cos theta. Because this is the angle, so I'm going to apply like this. And then I'm going to take the dot product with distance. Or I can write like this, F T cos theta is the formula. Remember, dot product formula is two vector we are multiplying, so force distance, they have dot product, and cosine theta is the angle between everything. So what I'm going to do, I'm going to be writing everything here. W equals to 1600 and then D is 2000 and then cosine 25. We solve them, the answer would be 29001,849 Newton, because the force in unit is Newton, this distance unit is meter, so it's going to be Newton meter. I can write this Newton meter called Joule or J. So really I can rip out this Newton meter and I can write J. Another thing is pretty big term. I can write kilo, so 1, I'm going to move this thing by 3, so I'm going to say 2900 point. Round off this 184, I can make it 2, and I move 3 decimal places, so I can say kilo Newton meter, And I don't want Newton meter, so I can write joules. So maybe I can just rid of this, writing joules. And that is my answer.